Look, thanks everyone for taking the time to join the webinar. So building the best foundation for horticulture crops. My name's Mick Darling and I'm with the Loveland Crop Nutrition team with Nutrient Ag Solutions based out of Melbourne. We'll look to aim to keep the webinar to 50 minutes or so in order to allow some time towards the end for some Q&A. So we're fortunate to have two presenters today who are experts in their respective fields. Dr. Brian Cornelious is the Director of Applied Sciences with Agricen based in the USA. And Agricen is a subsidiary company of Nutrient Ag Solutions who specifically research the role of bacteria to develop and bring to market technologies that contain very diverse biochemistry. Brian spends a lot of his time within the nutrient retail business, out in the network educating consultants and growers about the importance of soil health. So today he'll be explaining these unique technologies, their mode of action, and specifically how Foundation LM can improve nutrient use efficiency of our horticultural cropping systems. Also presenting today is Dr. Doris Blaesing of RMCG ag consultancy firm in Tasmania. And Doris holds a PhD in horticulture, specialising in orchard physiology and nutrition, and has extensive experience managing projects that focus on soil health in horticulture, including nutrition, irrigation, cover crops, and soil amendments. Today, Doris will be presenting factors that affect soil health, root development, and nutrient and water availability. So the main purpose of today's webinar is to explain the processes taking place within our soils and how they relate specifically to our horticultural cropping systems. By the end of the webinar, hopefully we'll all have a better understanding of how we can influence this living system with our biocatalyst technologies to improve plant health, crop yields, and overall crop quality. So with that, I'll hand the reins over to Doris and she can take over from here. Thanks, Doris.
Good morning, everybody, and welcome to this webinar. In my presentation, I will mainly talk about orchards. However, the principles of managing soils for good root development and good water holding capacity applies, of course, to vegetable and other crops. So please, the next slide. So what we just briefly in this short time want to talk about is basically the soil health and the interaction between the chemistry, physics and biology. A lot of people mention them separately, but obviously they're very much interconnected. What does that have to do with root growth and rhizosphere conditions? And then, of course, interactions between the root, water and nutrients. And you can see on the little image on the side, there's certainly quite different conditions in the different horizons. And often we forget that roots actually go much deeper than the topsoil. So for some crops, especially trees, we have to consider that. Thanks. Next slide, please. I often ask you, why should you care? A lot of post-harvest issues in all crops, but these are examples from apples, are actually disorders that are introduced into the fruit or into the vegetables very early in the crop. And even the later testing of nutrients will not give you the right answer, because the problem appears very early on. And in apples, all these nice images or bad images you see are very much related to calcium uptake. Next slide, please. Oh, and here actually my little reminder that came up. I think we passed the time where people use fertilizer recipes, so it's very important to understand the conditions of the site and the orchard that you're working with, or the vegetable crop you're working with. The main issues in Australia, and I guess really internationally in soil health, is the loss of organic matter. The main thing in vegetable crops would be tillage and bare soil, a big factor in soil loss. In orchards, it's quite different. We found that keeping the herbicide, a very strict herbicide program, and keeping the soil bare, like in the picture you could see in the top right, is usually not a very good idea and can lead to severe compaction and issues in the root zone. That's when you get more soil-borne pests and diseases and weeds happening. Loss of organic matter leads to soil structure decline. There are obviously other issues with compaction, like driving on the soil. However, loss of organic matter is a big factor in it. And as soon as you lose organic matter and you have compaction, there will be less water holding capacity, less drainage, and the soil is just far more difficult to manage. So you need to irrigate with less water more often, because there's just not enough room in the soil to hold the water. In Australia, we unfortunately have added challenges in a lot of areas. Salinity is, due to dry conditions, getting worse, saline water, but also there are problems with acidity and in sodic soils, alkalinity. So, and the subsoil constraints, especially in orchards, but also in broadacre crops, we know a lot about that in Australia, but we can't get into the details. However, what I can say, if you look at my bottom right image, adding and keeping organic matter in the soil is a bit like black magic. It does level a lot of issues and makes things easier to handle. Next slide, please. In orchards, using ground cover, whether it's actually living or dead mulch, doesn't really matter. In these images, I'm showing you some living mulch, and having mixed cover crops can, even if they're only used for brief periods of the year, can have a huge influence. And even if they're only in the center aisle of in the center strip, it makes a difference. If you can have a look at the top right image, that's what you can get if the soil is just heavily managed with herbicides. You get this moss cover, and you even get salt crusting on the top. So managing nutrition and irrigation properly in situations like that is very, very difficult. The next one, please. Rhizosphere conditions and root distribution. I think there are books written about it. But the really important issue is obviously the better your root growth or the growth of your crop, which really is, early establishment is really important for that. The better you will have, opportunity to take up nutrients and water. For instance, lettuce crops have very weak root systems, so that they seem to be needing more water than you would think a small plant will use. So what you will be looking for is good root establishment and good organic matter, and tilth, not tilth by rotary hoe, but tilth by actually being gentle with the soil is very important. If you can see the top right image, that's you see the soil cover on the roots. That's what really the rhizosphere is. And you can see in that plant, that's actually quite a young weed plant growing in very good conditions, having very good interactions between the plant, the soil, and the microbes that actually feed on the root exudates. So it is a very complex system. However, in good soil conditions, it will happen more or less automatically. And organic matter, again, adding organic matter is the key to keeping the soil healthy. The next one, please. This is an example of a soil in an orchard, not obviously looked after very well. You can see the topsoil has organic matter, but it's pretty dense, and the root system is going where there are some cracks in the soil and where it can go. And looking at the irrigation system with the blue kind of dyed water, is the water does not necessarily go where the roots are. So it is important not only look at the soil health, but also to actually have a look in an orchard where the roots are and where the water is going. It seems to be a very often forgotten thing to do. Can I see the next one, please? This is a bit of a story very quickly where the nutrition of, or the functioning of the orchard didn't really have anything to do with what the grower was monitoring in between the trees, nutrition or irrigation. And when we actually had a good look, we saw that most of the feeder roots were actually in the interrow. And the reason for that was, again, that the soil under the trees was completely crusted, full of moss, and the water was running off in the interrow. So all the nutrition and water uptake happened in the interrow, all the monitoring happened under the trees. So again, looking at where the roots are and making sure the roots are actually where they can easily take up water, for instance, in the topsoil, which didn't happen here, is very important. So get your shovel out and have a look. Next one, please. So to actually be able to distribute and hold more water, it is very important to look after soils. And as I said, in vegetable crops, it's a bit different than in orchards. You have the ability to use soil amendments or to use cover crops and strip tillage or minimum tillage to actually create a very good root zone. And there are a lot of recent biological products and other products that would help to further enhance root growth and nutrient and water uptake. However, if you use a soil that looks a bit like the one on the right side, it again has got poor water distribution, adding products to fix stuff will not work. So you really need to think about improving soil structure and conditions first, or in combination with products. But the products alone will struggle if the soil condition generally is not good. Next one, please. And looking at what we talked about good root distribution is actually really important for nutrient uptake. As you know, there are 3 different ways of nutrients getting to plants. Nitrogen going with mass flow, just with the water. Again, if you have a water distribution like I've shown in a couple of pictures, it will be very hard for the nitrogen to get to the roots. And sometimes I fear that over application of nitrogen is done to compensate for the very poor distribution and water distribution. With diffusion, it is very important again to have good root length density, good root density, because the way it works is that the water and nutrient uptake creates a zone of depletion around the root zone. And that then causes other nutrients to come and fill that gap. If you don't have dense nutrients, the diffusion will be slower or not as effective, because you're not lowering, or the plant is not lowering the concentration of nutrients in the root zone. So again, having good root distribution is really important, and that has to happen early in crop establishment. Then nutrients like phosphorus and also calcium to a degree have to be are mainly actually taken up by root interception. Most phosphorus sources don't move very far in the soil at all. People say about 2 or 3 centimeters or an inch. So by having poor root distribution, phosphorus uptake will be poor. So there are some principles to remember. And that's the reason why you want to have good root growth, and why every agronomist should have a shovel in the cow spade and have a look. Next one, please. Important, obviously, if you deal with orchards, is that there are different growth stages. And certainly, when there's fruit, young fruit growing, shoots are growing, and also fruit is actually, if you just click here, we will get another image in there. Could you do another click? Yes, thank you. So a lot of people forget that the flower bud initiation actually happens at the same time as this year's fruit growth, or the same year's fruit growth, which means if the trees get stressed early on when they're producing fruit in that time, you will also affect the flower bud initiation for the following year. So for trees, you really have to look at 2 or 3 years together to look at, doing the nutrition right. And you can see in that image that shoot and root growth are not happening equally at the same time. So there's not much point, having a lot of early nutrients put on, for instance, in trees, because especially nitrogen uptake occurs from the reserves of the tree. However, we found with especially some of the large-scale apricots and large-scale fruit, where everything happens very quickly, cherries, apricots, that applying a calcium, and that's soluble calcium, not gypsum or lime, very early on, even early flowering, will really help fruit quality and fruit development. So that might be something to remember. In vegetable crops, again, growth stages are really important. If you look at potatoes or tomatoes, for instance, or other crops, cotton, where there are stages where the plant grows absolutely rapidly, it needs a lot of, especially for instance, potassium. And even though some soils, according to soil tests, are quite high in potassium, you can get in these rapid growth phases potassium deficiency. So it's quite important to watch that and maybe even use foliarly applied potassium and nutrients to make up for it, especially under saline and sodic conditions. Next one, please. So for orchard nutrition, you really have to think about the site you're working with, the variety in the rootstocks. Certainly the weaker rootstocks need more pampering. That doesn't mean more water and more nutrients, but it needs to have it dished out more often in small amounts. Orchard floor management can make a huge difference. If you see the root systems, the poor root systems I showed you, will obviously nearly require more fertilizer, even though on the other hand, it might make the condition worse. So it's really quite important to understand the orchard and the conditions in the orchard to make changes to the nutrition. Topsoil depth is very important, and subsoil conditions. I've been to orchards where people had problems with nutrition, problems with irrigation, and had never taken a subsoil soil test. And often we found that the subsoil is sodic or acid or has got problems that actually affect root growth and affect nutrition. So if you work with orchards, but even with other crops that are vegetable crops, to do the odd subsoil test is quite important. Again, temperatures, when it's really cold, plants might look quite miserable. However, giving them fertilizer then is not really the fix, because it's just a temperature effect, and sometimes it's a waterlogging effect that makes the crop look unhappy. And we found that rather than applying a lot of fertilizer, adding a foliar fertilizer does actually help them to perk up a bit. But again, the main issue you have to really watch out for is to develop good root systems in a healthy soil in the first place. The next one, please. And I guess one of my major messages is monitor to manage. I know that not even most vegetable growers take soil tests. I think giving any fertilizer recommendations without a soil test shouldn't be allowed, really. And usually you get the money back. I remember doing some work with a grower who hadn't done any soil testing but had a fertilizer program, recipe program, and the soil was so doused up with phosphorus and potassium and other nutrients that he could actually go a couple of years without actually adding any fertilizers, but certainly needing to improve the soil. So that's why I'm showing you this image of doing the visual soil testing. If you have a cloddy soil, like on my score sheet of score 1 to 2, it's actually, I mean, I've seen people actually trying to grow potatoes in soil like that. Any nutrition program will not work, because it's just not a soil to grow crops in. If you have score 9 to 10, which doesn't happen very often, but we're getting there with good soil management, you will usually find that people need less fertilizers, less water, irrigation, and have more resilient and more healthy crops. So the visual soil assessment should be part of any soil sampling, and keeping notes of changes and improvements. And I think that's really in a very quick overview of looking at soil health, roots, and the importance of getting that right to actually get the nutrition right. Next one. Here, so that's all from me. You can see that the logo of the Soil Wealth project. So if you want to learn more about nutrition and about managing vegetable soils, have a look for Soil Wealth. You can just do the www.soilwealth.com.au. There's a huge amount of information on managing vegetable crops and soil health under Australian conditions.
And what we want to do is take all of those concepts that Dr. Blaesing talked about and introduce what can potentially be a solution to some of those issues that you may encounter in the field, and that is Foundation LM from Nutrient Ag Solutions. Just a basic definition of Foundation LM, it's an innovative fertilizer biocatalyst unique to Nutrient Ag Solutions, specifically formulated for use with liquid fertilizers, liquid in-furrow injection, and fertigation. So that's the basic explanation of Foundation LM. Now let's get into some of the other key benefits and features of Foundation LM. So that is increased nutrient availability and improves plant performance, contains diverse biochemistry, the byproducts of living system. We also call those microbial metabolites. It's compatible with a wide variety of liquid fertilizers, herbicides, fungicides, and other crop inputs that are being used. Effective in a variety of soil types. It's not soil type specific. It's not crop specific. It's very diverse. And then it's a very consistent and stable formulation that, again, blends well with almost any nutritional or crop protection input that you're putting out there. But again, Foundation LM is designed to go into the soil system. I want to really quickly give you a sense of how we actually come up with this Foundation LM product. We do have a biological process. What you see here on this slide on the left-hand side, that's a picture of some of the bioreactors that we have. This picture is of our plant in Denton, Texas in the US, but we also make our product in Australia just outside of Melbourne and Dandenong. So we have a plant in Australia where we make Foundation LM. And the end result is what you see on the right-hand side is that beaker or finished product. It almost looks like if you were to go to a very large banquet and they're fixing iced tea for everyone, it's generally not going to be the strongest tea that you've ever had because they have to make so much of it. So it's very light amber color, very clean product. There's no solids in the product. It's very, very clean product. It does contain some microbial content, mainly spore-forming bacillus species, but at the CFU counts, or the colony-forming units, when you compare that to other living microbial products, it appears to be very low. And I'll explain that in more detail as we get into the presentation. It is more of a biochemical product or a biocatalyst than it is a microbial product. And this is another reason why we say it's more of a biochemical product. When you take the Foundation LM product and you run it through a mass spec, the chart you see or the graph you see in front of you is what we get when we do a mass spec of that Foundation LM product. Again, it's a biological process, but it's more of a biochemical product because we find all of these individual metabolites or biochemical compounds that are in this product. Again, biochemical product versus microbial. And just some of the evidence of that, you can look on the bottom part of this slide. We won't go through all of those, but you can see that there's several different compounds that you may recognize. Up to 15 amino acids have been identified. Of the 20 base amino acids, we found traces of 15 of those 20. And then there's other organic compounds and things like that. So again, this is what you're getting with the Foundation LM versus just adding living microbes to the system. Any microbe or organism that's in that Foundation LM product is a dormant bacillus species. Now, when they actually are exposed to an environment that's conducive, such as the soil environment, a healthy soil environment, those organisms will wake up and start the process of doing exactly what you see here, which is to find a carbon or a food source in that system, metabolize that, and then produce what you see in front of you, these compounds. We just take that process and we do that in our plant, and then we apply those metabolites directly. So now let's look at some of the key differences when you look at what's in Foundation LM versus what may possibly be in some other microbial products that you may have used in the past. What we see here is a couple Petri dishes. And on these Petri dishes, that's a representation of the microbial content. That's what actually, from a microbial standpoint, what's in that product. And you can see that representation by how many or how densely populated this Petri dish is. From a simple biological standpoint, which is a chicken manure, I think you guys call them chooks in Australia, it's just a simple compost tea-like product. You can see that there's a pretty high number of CFUs of microorganisms, pretty densely populated on that Petri dish, versus the Foundation LM, and you can see /basis, which is the sister product for dry fertilizer. We won't talk about that in this presentation, but you can see that there's a pretty huge difference in the number of organisms that are in the product. But the key, again, is what are the metabolites that are being produced? What are these compounds that are actually working in some of these soil chemical reactions? So we have these, what we call biolog plates, and these 96 well plates give you an indication based on a color change of how diverse those metabolites produced in this product are related to known carbon sources that are on this plate. And the way this plate is organized is there are more simple sugar type compounds at the top, going towards the bottom, more complex carbohydrate type compounds. So you can see in this simple biological or this compost tea type product, there's several reactions with more of the simple sugar type compounds. And it could be because a lot of those organisms may be or may have an affinity to some of these type of carbon sources versus what you find in the Foundation LM product. And you can see that this product is very, very diverse. There's some advantages to that. Again, that when I mentioned earlier that the product is not soil type specific, it's not crop specific, it's not region specific. These are some of the reasons why, is because the metabolites in this product are so diverse and cover such a wide range of geographies, crops, soils, and different cultural practices. So that's kind of what's in the product. So now let's move a little bit further and just kind of show you some of the work. This is not all of the information. This is limited to Australia. Over the years, Agricen moved into Australia. We established Agricen Australia, which, like Mick said at the beginning of the presentation, we are a subsidiary of Nutrient Ag Solutions, and we have done a fair amount of work in trials around Australia. And this is just a quick representation of where some of the work has been done. That work is ongoing. We're also, we started in the United States. We have product in Canada. We have product in South and Central America. So the product covers a very, very wide geography. And there's no difference in how we produce it to go to different areas. So again, that diversity is one of the key strengths of the Foundation LM. Now, let's break this presentation up a little bit into two segments. We've got our permanent crops, where we're talking about the benefits being more related to a lot of the concepts Dr. Blaesing talked about, the rooting or that root flush, water utilization, how does that affect the canopy, and how do we manage the soil? Here, from the soil compaction standpoint, which could be physical or chemical, versus what happens in short season fruit and vegetable crops, where there's different things that a grower in these two segments may be looking at. In the short season, things happen very fast, so it may be a very uniform germination, very fast nutrient availability, a more uniform harvest to prevent extra labor from going out, and then the market quality. Again, it's all about, even if your yield is the same, if your quality is better, then there's a chance that you can actually gain more profit on that crop. So two very different segments, but a lot of the concepts will cross the permanent crop and short season vegetable lines. So let's start talking about some of the trees and things that are happening in our permanent crops. And again, like Dr. Blaesing said, soil conditions, rooting, they're very key to the success of having a successful harvest, or even healthy plants and healthy soils in these different systems. So I want to take you just to some pictures that we pulled when I was putting this presentation together. I was like, okay, how do I find, or can I find any information in trees where we actually have a representation of difference in rooting? And it's a little bit more difficult when you sample roots on different crops, because there is some destructive nature to that. But when I found a study that was done in Chile on cherries, which we've been working in cherries in Chile for many, many years, you've got these grids that are placed, and the roots grow out against these grids where you can actually do some measurements. So you can see on the left is an untreated system. You can see roots there, but you can see that there's a difference. It looks like there's more roots. That root system is more dense. There's more places for those plants to take up nutrients and water and things like that. Like Dr. Blaesing mentioned, you know, a lot of the root interception nutrients and things like that. You've got to have that physical contact with the roots, and those nutrients don't move very far at all. So you can see on the slide as well some of how that program was designed. There was different applications in January, September, and November of that year. And then we go back in January of the following year in 2011 and look at the difference in the rooting of these cherry trees. And then we can also look at another issue that Dr. Blaesing talked about, where we're dealing with salts or salinity problems. These were walnut trees in Yuba City, California, and you can see on the untreated side where the problem was so bad that you can see actual physical signs of salt present on the surface, versus where we treated with the foundation LM. The issue that really made a huge difference in this walnut orchard was water penetration. On the untreated side, it was very, very difficult. No matter how much irrigation water was applied, the water wasn't penetrating. The soil was basically what we would call chemically compacted, versus where we applied the foundation LM, just banded over the irrigation furrow at 15 liters per hectare. You can see no presence of the salts, as well as what we know about the study is that water was penetrating in the orchard and making a huge difference in the system. Now, I'm not telling you that if you have a salt issue, that foundation LM is going to completely solve your salt problem. But what we're seeing is that it can help cycle or move some of those salts through the system to actually give the plants a chance to actually take up more nutrients and water without having all of those salts present there at once, and help relieve that system in some instances. But again, I'm not telling you that it's completely getting rid of the problem, especially if the problem is your irrigation water. That irrigation water is going to continue to bring that problem back around. But what we see here is that we can manage that with the Foundation LM. What about a 40-year-old vineyard? 40-year-old Zinfandel vines that were really having trouble. The production was reduced. We had some issues with annual rainfall. They were watering really heavily to try to keep these vines productive. Looking at the temperatures that were the vineyard was being exposed to, and the yields, you can see that in the previous year where there was no treatment, average rainfall, but the number of watering hours, 152 watering hours. And then you can see the yield, 8.7 tons per hectare. So as you move down and look at what was done through this multi-year study, the first year of the Foundation LM treatment, a little bit more rainfall, but look at the significant reduction in number of hours. Now, what you would see here, the leaders use, it's almost like giving that vineyard an IV in that first year, and then the subsequent years reducing the amount, kind of like putting it on now a regular pill regimen of a lower dose. So basically what you see is less product used through the years, yields were being maintained, still higher than the untreated year. Sugars in most cases, or in half of those years of treatment, was increasing. The temperatures, as we get into 2005 and 6 and 7, you can see days above 38 degrees Celsius, days above 41, days above 43. The temperatures were increasing, but we're still maintaining a yield better than the year we had no treatment, and we're lowering our watering hours significantly less than what we had in that initial year. Just look at 2007, only 249 mils of rain, but still we didn't have to increase the watering hours above that untreated year in 2003. So just more evidence that, again, the product is helping to improve water penetration, helping to improve the soil health, helping to improve the productivity of these very older Zinfandel vines. So let's look at how all of this is able to influence that system. So here we've got a system that we've treated with the Foundation LM, and you can see based on the illustration that what we're helping do is manage some of the interactions between nutrients in that system, like calcium and phosphorus. Calcium and phosphate at high pHs love each other. I mean, it's a marriage that will never end in those higher pH situations. But if we can break some of those bonds between those cations and anions, then we can use other things in that system to help manage it better. If we've got a lot of calcium there, if we can break the calcium phosphate bond and there's hydrogens in that system, whether it's hydrogens that are given off by the plant roots or hydrogens that are in that system that were moved off of the exchange sites by free calcium, if it combines with that available phosphate, it can create more plant available phosphorus. As well, that calcium, if it's liberated from the phosphate, it can actually displace sodium on the exchange sites and create a system that's more usable because of a lower amount of sodium in that system at that time. So this is one of the ways that the Foundation LM can help influence that system. And calcium is also pretty important as when we look at the ability of it to flocculate the soil and create better soil environment. So results you get there, you can help create more nutrients, you can help increase the plant rooting because of the healthier system that you've got, and then you can also, with some of that free calcium, help to improve the soil structure as well. So that's a little bit about how we think that Foundation LM is working in that system. So let's move to the second phase when we're talking about some of these shorter season crops. So the fruits and vegetables, again, some of the goals may be different because these seasons are so short. We have to really make sure that we get things off to the best start as far as germination, nutrient uptake, maximize our rooting potential to take up more nutrients and water, to create what you see in this picture. On the left, the control versus the right, where it's treated with foundation. That's 2 applications. First application 2 weeks before, and then after planting. And you can see the difference on the left and the right just by adding the foundation in there. Very, very uniform crop on the right-hand side treated with foundation LM versus a less uniform. And you can even see that there was some plants that the density doesn't look as good. There were probably some plants that didn't make it for various reasons, probably nutrient uptake or other problems, but you can see the difference in the very short season crop there. So what about strawberries? It's not necessarily a short season crop. I mean, those berries are picked over many weeks, but again, you've got to make sure that you get those nutrients available to the crop, make sure you've got enough water, and that you have marketable fruit. So we can see here the standard farmer practice 1 and 2 versus 10 liters of foundation LM per hectare, and then 20 liters of foundation LM per hectare. First, the amount of waste per hectare. You can see that there's a slight reduction with the foundation LM, and then yield. Tremendous increase in yield with the foundation LM. Again, it speaks for itself when you look at these differences of how much influence these applications can have in your fruit and vegetable crops as well. So let's do a quick summary, and then we're going to get ready to answer the questions. The foundation LM, again, fertilizer biocatalyst formulated for use with liquid applications. And we've talked about those benefits of increased nutrient availability and uptake, and again, improved plant performance. And we've looked at different scenarios. We're still talking about horticulture as a broad topic, but we're talking about what we can do in the permanent crops versus the shorter season vegetables to achieve our goals using this technology, and also just reinforcing some of the concepts that Dr. Blaesing talked about of what the potential is for the foundation LM to influence some of those parameters.